Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 1 Notes 4, which is graphing and writing equations in any form. So we've already talked about slope-intercept form of an equation and we've talked about point-slope form of an equation. Today we're going to talk about standard form of an equation. So this is our third form of linear equations. And it looks like this. Standard form is the form a times x plus b times y equals c, where a, b, and c are constant. There is no slope or y-intercept in this form of an equation. A lot of people want to look at that a value and call it the slope because they're used to slope being in front of x, but that's only true when y is by itself. And here we have the x term and the y term together on that left side. So a is just a constant, b is just a constant, and c is a constant. So now what we're going to do with this form of an equation is we're going to make sure that these constants, this leading coefficient, is positive. We're also going to make sure that A, B, and C are integers, meaning whole numbers of some sort, with that leading coefficient positive. So this could be negative and this could be negative, but that first number is going to be positive. We're also not going to have any fractions, okay? So those are the two things we want to check out for. We use this equation to model situations that are given two variables. A lot of situations that we read are going to be best modeled using a standard form equation. So let's just do some practice. Let's put the following equations in standard form. So number one, I need to get the x term and the y term together on this left side, which means I need this constant to move over. On the right-hand side, I want to keep the constant, but I want the x term and the y term to move back. So that means I'm going to subtract 4 from both sides. And since 9 and 4 are constants, that's what's going to go together. If it helps you, you can draw that kind of railroad track down the middle. So I have 6x minus 2y is equal to 9 minus 4 is 5, minus 5x plus 2y. Now I need both the x term and the y term to move back over to the left because I want them together on the left-hand side. So I'm going to add 5x, and at the same time, I'm going to subtract 2y. I can do those two in the same step since they're not like terms, they don't affect each other. So, and I don't have any distribution going on, so I can do them together. So I'm going to add 5x, and I'm going to subtract 2y and see what that gives me. 6 and 5 is 11, so 11x. Negative 4y or minus 4y is equal to the constant that was still there, 5. The last thing I check for is my leading coefficient positive? Yes, it is. And are all of my coefficients and constants whole numbers? And yes, they are. I have no fractions or decimals. So that is my standard form equation. Let's take a look at number 2. Now I have 6x minus 5y minus 7 is equal to 8 plus 2 times the quantity 3x minus 7. Now we learned when we were solving equations that the very first thing we have to do is distribute that 2. So I have negative 6x minus 5y minus 7 is equal to 8. And then I have plus 6x minus 14 after I distribute that 2. Remember that distribution is multiplication. So I need this to move over. I'm going to add 7. So I have negative 6x minus 5y is equal to 15 plus 6x minus 14. The 15 and the 14 can go together. Those are both constants. So negative 6x minus 5y. Since they're on the same side of the equal sign, remember that equal sign's coming right down the middle there. They're on the same side of the equal sign, so it's not like I'm canceling 14 to the other side. I'm just putting these two like terms together. 15 minus 14 is 1, so I have 1 plus 6x. But now I still got to get that 6x to move over to the other side. So negative 6x, negative 6x, so that's negative 12x minus 5y is equal to 1. Now, when I look at this equation, I'm really close to standard form. I have the x and the y term together. I have the constant over on the other side. However, I have no fractions and decimals, which is good. However, this leading coefficient is negative. I need this leading coefficient to be positive. And in order to make it positive, I need to multiply the whole thing by -1. When I do that, that makes that a positive 12x. That makes that a positive 5y. And I even go across the equal sign to that constant because I can't just change the left side. I've got to change the right side as well. So that's going to be equal to -1. There's my standard form equation. All right. Let's take a look at number 3. Write the equation in standard form. So this equation is given to us in slope-intercept form already, which is not so bad. I need to just take this x term and move it over to the other side. So that's what I'm going to do. Subtract the 2/5 x, subtract the 2/5 x. So x and y don't go together, so when I write them, it's just going to look like this. -2/5 x plus y is equal to -3. Once that's gone, I have -3 left over. Now I have two problems. This is both a negative number and it's also not an integer. It's not a whole number. So that means I've got some multiplying to do. To get that denominator out of its denominator position, that 5 that's down here, because that's really my problem, I'm going to multiply by -5, but by +5. But at the same time, this is a negative number that I want to be positive, so I'm going to make that 5 negative because that's going to give me a positive whole number coefficient. That's what's going to get distributed to all three parts. So -5 times -2, this 5 is going to, or -2/5 I should say, this 5 is going to cancel that, and then I really just have a negative times a negative, which is +2. Okay, so the 5 in the top canceled the 5 in the bottom, the negative canceled the negative, I'm left with a +2. That's with my x term. Then I have -5 times y, that's -5y. Then I have -5 times -3, that's +15. Okay. In number 4, I have -5x plus 11 is equal to 1/2 y. So I need to take that y term and move it over here, take the 11 and move it over there, and see what that gives me. So my 5x doesn't change, -5x is still in the front. Now I have -1/2 y, and then I have -11 on the right. Okay, so again, I have this fraction here that I need to fix, and I also have a negative coefficient in the front. So that means I'm going to need to multiply by whatever my denominator is, because that's going to cancel that denominator. So I multiply by 2, because that'll cancel this denominator. And then I need this negative to be a positive, so I'm going to multiply by a -2, because a negative times a negative gives me a positive. So when I distribute that, -2 times -5 is +10x. -2 times -1/2, this 2 cancels that, negative times negative is positive, so it's just +1y. And then -2 times -11 is +22. Now you could do that in 2 different steps if you wanted to, if it helped you to break that up a little bit more. You could go through and multiply by the 2 just to get rid of the fraction, and then you could go through and multiply by a negative to get rid of that negative leading coefficient. That would work as well. I just did them together to save myself a step. Either way is fine. All right, number 5, I have a point of -8, 1, and I have a slope of 3/4. I need to write an equation in standard form. Since I'm given a point and a slope, I'm going to start with point-slope form. So I'm going to start with y minus 1 is equal to 3/4 times x plus 8, because that's minus -8, which is plus 8. Then I need to distribute that 3/4. So y minus 1 is equal to 3/4 x. And then 8 divided by 4 is going to give me 2, and 2 times 3 is 6, so plus 6. I need this 1 to go to the other side, and I need this 3/4 x to go to the other side. So I'm going to add 1, I'm going to subtract 3/4 x. I'm doing them in the same step. So I have negative 3/4 x plus that y that was just there and we haven't changed anything is equal to the 6 plus 1, which is 7. All right, so now I've got the x and y term together on the left, constant over there on the right, but I need to make it a positive, I need to make them integers, and I need to make the leading coefficient positive. So I'm going to multiply the whole equation by 4, because that's my denominator that I'm working with. And I'm going to also multiply the whole thing by a negative, because that'll make that leading coefficient positive, which is what I want. So I distribute that across. This 4 cancels that 4, and I'm left with positive 3x. Then I cross through it, so I'll just write it again. This is a negative 4 that I was distributing. So negative 4 times y is negative 4y, and negative 4 times 7 is negative 28. And there's that. Next one, point slope. So again, I'm going to use point slope. So I have y plus 2 is equal to 5, which is my slope, times x minus 3. So this gets distributed. That's y plus 2 equals 5x minus 15. Subtract 2. I've got y equals 5x minus 17, and then move my 5x back. I could have done those in the same step, but that's fine. So negative 5x plus y is equal to negative 17. I want that whole thing to be positive, so I'm going to just multiply by a negative 1, because that's going to make my leading coefficient positive. So I have positive 5x minus y is equal to positive 17. And there's my standard form equation. Ooh, now we're just given 2 points. So before we can do anything, we need to know a slope, because I can't do anything with this until I have a slope. So I'm going to find the slope first. My slope is going to be 3 minus 1 on the top, y minus y, and then 1 minus 2 on the bottom. So it's the y minus y over x minus x. 3 minus 1 is 2, 1 minus 2 is negative 1, that's a negative 2. Now, I just pick one of the 2 points to use point slope form. It doesn't matter which one I use, they're both going to give me the same result. I'm just going to pick the second one just because that's what I feel like picking. So I have y minus 1 is equal to my slope, negative 2, times x minus 2. Distribute that. So we're kind of going start to finish with all forms of an equation in this question. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. I need the x term to move over, and I need the y term to move to the other side. So I have 2x plus y is equal to 4 plus 1, which is 5. Whole number, whole number, whole number, leading coefficient positive. I'm good. That's my standard form equation of a line with those 2 points. Let's try that again in number 8. So again, I'm given 2 points, and the only thing that you can do with 2 points is to find the slope. That's it. So that's what I have to do first. So I'm going to take 3 minus negative 5 and negative 4 minus 0. So y minus y on the top, x minus x on the bottom. So plus a positive, that's 8. Negative 4 minus 0 is negative 4. Slope again is negative 2. What a coincidence. Now, I recognize something. I have an x value of 0. Anytime I have an x value of 0, that means that is my y-intercept. If that's my y-intercept, I can skip point slope and go straight to slope-intercept. So when I write out a slope-intercept equation, this is my y-intercept and that's my slope. That's y equals negative 2x minus 5, because that x value is 0. So I'm kind of taking a shortcut here because of the points I was given. Now you could have gone through the hassle of doing point slope form and you would have come up with the same answer. That's just fine. But I like to recognize shortcuts when I see them. So if I see that x is equal to 0, I know that's my y-intercept. I'm just going to write it in slope-intercept form, and then I'm good. So now I'm going to add 2x to the other side, put it in standard form, 2x plus y is negative 5. Leading coefficient is positive, all numbers are whole numbers, and I'm good. Now we're getting into the writing part of this section. So in number 9, it says you have $10 to buy carrots and tomatoes for a salad. Tomatoes cost $2 per pound and carrots cost $1.25 per pound. So I want to write a standard form equation with integer coefficients for this situation. You have two variables going on. You have carrots and tomatoes. I'm just going to call x carrots and y tomatoes. Some of you may have chosen to do vice versa. It wouldn't matter. It means the same thing. So as long as you tell me which one it is, as long as you label them, notice that that's the first thing that I do. So that's a little note you need to write yourself to remind yourself. First, label your variables. Okay, we're going to have that a lot this year. So when I write this out, tomatoes cost $2, so that goes with the y. Carrots cost $1.25, that goes with my x. So my equation looks like this, 1.25x plus 2y. The total dollar amount that I have to spend is 10, so is equal to 10. Now, I'm really close. All of my numbers are positive, and I really only care about the first one. The leading coefficient is positive, which is great, but the leading coefficient is also a decimal, and that's a problem because that is not an integer. So I need to make this an integer. Now, when you think about 0.25 as a fraction, 0.25 as a fraction is the same as 1/4. So I'm going to take this equation and I'm going to multiply it by 4 because that's going to get rid of that 0.25. It's kind of like the same way as saying there's 4 quarters that make $1, one whole dollar. So I need to multiply by this quarter by 4 to get one whole dollar. Now don't forget about the one that's in front. So I take 1.25 and multiply it by 4. This is going to go all the way across. So 1.25 times 4 is 5. So I have 5x, then 4 times 2 is 8, 8y, and 4 times 10 is 40. That is my standard form equation with integer coefficients. In number 10, it says you're moving into a house. You can carry 56 pounds at one time. A box of books weighs 18 pounds, and a box of clothing weighs 10 pounds. So my x and y are books and clothes. Now again, if you switch the way your variables go, sorry, that was really bad handwriting. If you switched where your variables went, that's okay. You could call y books and x clothes. It doesn't matter as long as you tell me. Okay, so one box of books weighs 18 pounds. That means I have 18 times x, and one box of clothing weighs 10 pounds. So I'm adding 10 times y, and that's going to equal the total amount that I can carry, which is 56 pounds. And there I have it. Standard form equation. All integer coefficients, leading coefficient is positive. I'm good to go. All right, so now we're going to get into the graphing portion of this equation, of this section. So we have in number 11 an equation in point slope form to graph. Now, there's a couple of different ways that you can graph this. One way is just to put it in slope intercept form. Find your y-intercept, find your slope, graph it from there. Okay, so if I did that, that means I would distribute the 2, and I'd have y minus 3 is equal to 2x plus 2, and then I would add the 3. So I have y is equal to 2x plus 5. So there's my slope-intercept form equation. That means I have a y-intercept of 5, which is way up there, and then I have a slope of positive 2. So I can go up 2 and be off my graph a little bit, or I can also go down 2 and left 1, down 2 and left 1, and make my line from there. Okay, now I want to show you the other way that you can graph this equation. Now, this equation is in point slope form. That means that this was my y value and this was my x value of some point. But I really need to take their opposites because this was x minus -1 to give me that +1 in there. So I know I had a point with a +1 x value, and over here I had y minus 3 I'm sorry, I know I had a point with a negative 1 x value because it was x minus negative 1 to give me that positive 1. Over here I have y minus 3, which is a positive 3 value. And that's my slope. So if you want to use the point that's given to you in point slope form and graph it that way, let's see what we get here. I'd have a negative 1, positive 3, there's that point, and I have a slope still of 2, so I'd go up 2 and over 1, and look at that, I'm on the same line. So my line would be the same. You either put it into slope-intercept form, or you can use the point that was given to you as long as you recognize that this was its opposite. So let me just show you what that looks like here in number 12. So if I use the point given to me, that means that this was a positive 3, because I have a negative 3 there, and this was a negative 4. My slope is 1/2. So here's what that line looks like. 3 negative 4 is over 1, 2, 3, down 1, 2, 3, 4. And then a 1/2 slope, positive 1/2 slope, is up 1 and over 2, up 1 over 2, or down 1 and back 2. Both ways work. So there's that line. If I went the other direction, let's just get rid of this stuff so we can see what we're working with. If I went the other direction and put it into slope-intercept form, let's see what it looks like. I would distribute the half. I'd have y plus 4 is equal to 1/2 x minus 3/2, and then I'd subtract 4. This is like negative 1.5 minus 4. So it's y equals 1/2 x minus 5.5. So my y-intercept is negative 5.5, which is about where I am on this green line. And then my slope is 1/2, so that's up 1 and over 2, which is right there. Up 1 and over 2. I'm kind of in the middle of those grid lines, but look at that. I fall right on the same green line that I did if I used the point that was given to me. Both ways work to me. It does not matter. Okay. In number 13 and 14, let's talk about graphing lines in standard form. So again, it's probably easiest just to go ahead and put it in slope-intercept, which means you're solving for y, getting y by itself. So it means I'm going to subtract 4x here. And then I have 2y is equal to negative 4x plus 8. And then I need to get that y alone, so I'm going to divide by 2. So I have y is equal to negative 2x plus 4. So if I graph that line, I've got a positive 1, 2, 3, 4. I can go down 2 and right 1 for my slope. Down 2, right 1, down 2, right 1. I like to make 4 or 5 points just because I think that gives me a more accurate line. It also helps if you use a straight edge. I don't have a straight edge when I'm working on a computer, but if you have like the edge of your calculator case or the edge of your binder, or if you had a ruler, that'd be great. And you can use a straight edge to make that nice straight line. Okay, but now here's the other thing about standard form. So when I look at standard form, I could also use the concept of the x and the y intercept. So we call this looking at, you know, this variable separately. So if I ignore this y variable, if I pretend that y is equal to 0, which would make that go away, that means I'd have a 4x is equal to 8. I can divide that 4 and get x equals 2. That's a point. That's a point 2, 0. If I do it the other way, if I get rid of the 4x and keep the 2y, and I have 2y is equal to 8, divide by 2, I get y equals 4. So that was x equals 0 because I made x disappear, y equals 4, there's my point, 0, 4. Now you only need 2 points to make a line, really, so I can use this point and this point. This one would be the x-intercept because it's where it crosses the x-axis. So 2, 0 is over 2 and not up or down at all. So there's my x-intercept. And this one is the y-intercept, 0, 4. There's that point right there. And I can connect those 2 blue points and check it out. Same as the purple line. So put it into slope-intercept form. That's one method, and that will work for you every single time. Or if you want, you can use the intercepts and you can graph it that way. Okay, let's try the intercepts first over here in number 14. So if I tell myself that x is equal to 0, then I have negative 6y is equal to negative 12. I divide by negative 6, and I have y is equal to positive 2. So there's a point, 0, comma, 2. If I flip that and tell myself that the y term is 0, then I have 3x is equal to negative 12. Divide by 3, and I get x is equal to negative 4. So then I'd have negative 4, comma, 0. So here's a point, here's a point. Let's graph them and make that line. 0, 2 stays on the y-axis and goes up 2. Negative 4, 0 goes left 4 and then doesn't go up or down at all. And I can use those 2 points to graph a line. Just this is when you only use 2 points, you got to be really careful to make it as straight as possible. Or I could go back to my original line. Let's get rid of this stuff so we can see the original equation. And I can put it in slope-intercept form, which means I would subtract 3x, and I'd have negative 6y is equal to negative 3x minus 12, and then divide by negative 6. So then that gives me y is equal to negative 3 divided by negative 6 is positive 1/2. That's 1 over 2, and negative divided by negative is positive. So positive 1/2 x, and then negative 12 divided by negative 6 is positive 2. So I'd have a positive 2 y-intercept, and look at that, I'm on the green line already. And then a 1/2 slope, I go up 1 and over 2, and check it out. I'm on the green line. So slope-intercept form works, or using the intercepts works. Slope-intercept form is mindless because you know you need to get y by itself, and it'll work for you every single time. But either way works for me, and I do not care. Thanks for tuning in. Don't forget to check your notes sheet off with Ms. Johnson, and I will see you next time.